in this part, they want us to take our equation that we found, which was C of x, the total cost of towing the vehicle was $3.50 per number of miles, and x was the number of miles, and there was a flat rate of $12 for a reservation fee. In this problem, we are to state the practical domain and practical range of C of x using inequality notation and include the unit. So my domain will be the x values that make sense to put in the equation, which in this story is the number of miles being towed. And my range will consider the set of outputs, normally y, but in this case we're not using the output variable y, we're using C of x in the place of y. And remember, that is the total cost in dollars. So the idea is, in general, if I just said here's an equation of math and I said what's the domain, the answer would be all real numbers, meaning that you could plug in any x value in the world and you can multiply any number by 3.5 and add 12 and expect to get a number out. Practical domain means listen to the story and what makes sense in terms of the story, what kind of values make sense to let x take on. So what is the smallest x value? What's the biggest x value? What's the domain of my problem here? So the lowest number of miles that you could be towed in my mind is 0 miles. So the smallest x value that I could imagine is if you don't have them tow your car at all, and that would be 0 miles. So then the question is, what's the biggest x value I expect to ever have to plug into this function? My biggest x value, and remember that x is in miles, in the problem they say that they will only tow a maximum of 30 miles. So the biggest x value that we would ever plug into this function is x equals 30 miles, because that's the furthest they're willing to tow. So the idea is my domain in inequality notation would be that my x values are between 0 and 30. So you could put this a couple different ways. You could say x has to be bigger than or equal to 0, and at the same time x would be less than or equal to 30. Sometimes we combine this into a compound inequality. Then what you do is you write your smallest x value, which was 0, your biggest x value over here, which was 30, slap a input variable in between and put on a couple less than symbols in there, and then decide whether there should be an equal sign here, or that line. And in this case, yeah, x could actually be 0. You actually could tow your car 0 miles. And then the 30, of course, they will tow your car 30 miles. So we'll put equality there. Now it said include units, so I should say x is greater than or equal to 0 miles. I should need to slip that in right there. And I should put 30 miles there. Since I already boxed my answer, I didn't leave myself room to write. In fact, this should be 0 miles, less than or equal to x, less than or equal to 30 miles. So it's always good to go back and reread the directions and make sure that you follow the directions. So I stated my practical domain, I used inequality notation, and I included the units. Now I'm going to do the range. It's the smallest output and what's the biggest output you can expect to get from this equation, given that you've restricted your domain to be x values between 0 and 30. So the idea is the smallest that my cost function could be, that's C of x. So the range is the set of all outputs. So range is set of all. You've probably heard y values before, but we're not calling our functions outputs y, we're calling it C of x. So set of all output values. So to figure out the lowest that my cost would go, the smallest C of x value I could get would be if we tow 0 miles. And I think we found that perhaps in a previous problem, I'm not sure. But if you had your car towed 0 miles, then there would be no $3.50 there, but there would be a reservation fee of $12, which in some ways isn't very practical, because if you got your car towed 0 miles, I would expect to pay 0. But to make sense of the equation, what we want to say is that you'd still pay a flat reservation fee of $12. So my range, the smallest value of the range, so smallest C of x value will be $12. Remember, I'm supposed to use units. So if I were to graph this function over the domain, when someone plugs 0 into this equation, they're going to get out 12. So you can think of it as, what would the graph look like if you were just plotting x values between 0 and 30? So the idea is that your range for this restricted domain between 0 and 30, your range would start at 12. That would be the lowest that it goes. And then, of course, it's going to grow in a linear fashion. And now I need to know how high it would go. So what's the biggest output you could get? Well, the biggest output would be found by plugging in the most number of miles driven. So you're going to get the biggest bill, the total cost is going to be the greatest when you actually have them tow your car the 30 miles, which is the maximum. And I might grab a calculator for this and see what that is, or I can just argue arithmetically that $3 times 30 miles would be $90, and then the 50 cents, imagine 50 cents per mile for $30 would be another $15, and then you have that flat rate of 12. So this would be 105, and then be 117. So I get $117. So my biggest value for C of X be $117. Now I'm supposed to represent this in inequality notation. There's a couple different ways you could say it. You could say my total cost C of X is bigger than or equal to $12. I'm put a dollar symbol there. Remember, we have to include units. And at the same time, my total cost has to be less than or equal to, that turned out to be 117. So this is equivalent to giving a student a graph and saying, you know, what's the domain and the range of the graph? You'd say, well, it goes between 0 and 30 on X, so that was my domain. And my range is the set of Y values, and in terms of heights, the lowest it goes is 12, and the highest it goes is 117. So back to this, your cost would be less than or equal to the 117, and the units are dollars. So either write the word dollars here, I'm just going to write the dollar symbol. If you want, that is the answer. Some students like it better if you put it in a compound form, where you put the C of X in the middle, you use less than symbols, you put the smaller number over here and the bigger number over there, and then you slip in either the word dollars, or I'm just going to put in a dollar symbol here. And that means that your total cost is between $12 and $117. But remember that it actually can be 12 and it actually can be 117. So we're going to put a line there to indicate that we are to include those values.